This is Mr. Clem from Clem Maths. Today we're going to go through the whole of straight line and higher maths. This is an updated video from my previous videos, so it includes the whole of teaching for higher maths straight line, but it also includes every single past paper in straight line, including the 2021 ones and last year's past paper 2023. Let's go with the full teaching, and then at the end you will see all the past paper questions, and it's split up by chapters, so you just click anywhere you want. Just look at the link in the descriptions. Okay, let's go. Distance form is just a way to visualize Pythagoras, essentially, to find the distance between 2 points. So let's say I've drawn a line on a coordinate grid. Let's call that coordinate grid y and x, just to be clear. And we've plotted 2 points. We've plotted point 1, which is x1, y1, and point 2, which is x2, y2. And it's a diagonal line. Well, I could make a right angle triangle by doing this. And the distance along the x would simply be the difference between x2 and x1. So that would be x2 minus x1. And similarly, going up the y-axis, the distance up the y-axis would be y2 minus y1. So by Pythagoras, we should already know from National 5 that we can do this side squared plus this side squared equals this side squared. So let's call this side d the distance. Then the distance squared would be x2 minus x1 squared plus y2 minus y1 squared. Or in other words, distance itself would be the square root of all that, which is x2 minus x1 squared plus y2 minus y1 squared. And you can extend that to 3D by adding a z-axis as well. But this is your distance formula. So whenever you've got to find the distance between 2 points, you can remember this formula and use it, or you can construct a right angle triangle and just work out your distances and use Pythagoras, your choice. Okay, example 1, A is the point minus 2, 4, B is 3 minus 1, calculate the length of the line AB. So to visualize that, we could have point A here being minus 2 and 4, point B here could be 3 and 1, and it's asking us the length of the line. So we need to know the distances x2 minus x1, so 3 minus minus 2, that would be 5. y2 minus y1, the distance between them is 3, so our distance is simply going to be the square root of 3 squared plus 5 squared. That's the square root of 9 plus 25, which is the square root of 34. And we can just leave that as the square root of 34 as a third in its simplest form. QR has these vertices, show that it's isosceles. So we can visualize P, say, Q, and R. And of course, this is not drawn accurately at all. I've not even checked to see if the relative relationships of where the points would be is correct. It's just to give me an idea. But essentially, if 2 of these sides are the same, any 2 of the sides, it is an isosceles triangle. So I just need to check my distances. So if I try the distance from P to Q, well, that's the square root of 5 minus 2 squared is 3 squared. 9 minus 3 squared is 6 squared. That's the square root of 45. Now we could do the distance from P to R. So we've got 8 minus 5 is 3 squared. And we've got 3 minus 9 is minus 6 squared. That is 36 plus 9, the square root of 45. And just a quick check on the last one, the distance from R to Q. 8 minus 2 is 6 squared, but 3 minus 3 is 0 squared. That's the square root of 36, which is 6. I've not even checked if I can simplify the surds to 45. Let me just double check that. 9 times 5 is 3 root 5. And that is also then 3 root 5 if you are simplifying them. But the key point is, since the distance from P to Q equals the distance from P to R, triangle PQR is isosceles. H, R, and C are vertices of a triangle, show that it is right angled and name a right angle. So again, I'm going to draw a non-accurate sketch but we've got H, R, and say C. We want to show that one of these angles is right angled. So let's get started with our distances. So the distance from H to R, we've got 7 take away 3, 4 squared plus minus 7 take away 5, minus 12 squared. 4 squared is 16, 12 squared is 144, so that's 160. 160 is 16 times 10, so we get 4 root 10. Okay, let's do the distance from H to C. So that's minus 15 take away 3, which is minus 18 squared. Minus 1 take away 5 is minus 6 squared. That's the square root of 360. That's 36 times 10, so that's 6 root 10. And our last distance, we've done H to R, H to C, so we need to do R to C. We've got minus 15 take away 7. That's minus 22 squared plus 6 squared. That's 520. So right angle triangle is by Pythagoras. Let's check the two short side squares and add them together. So let's look at our non-simplified ones because they're easier to square instead of trying to square these. So on left hand side, we've got root 160 squared plus root 360 squared, or in other words 160 plus 360, which equals 520. And our right hand side, we have got root 520 squared, which is 520. So since a squared plus b squared equals c squared by Pythagoras, we have a right angle triangle. Okay, now where's the right angle triangle? Well, we can now draw our picture. We know that R to C is the longest side. So if I just draw, that's R and that's C, that's my longest side. So H is here. So angle RHC is 90 degrees. Or CHR. Mr. Collinear here from Collinear Maths. Today we're going to be looking at calculating the midpoint between two coordinates for higher maths. So let's have a look. We have got drawn a line and we could define one coordinate as x1, y1 and the second coordinate as x2, y2. And we want to know what's the coordinate of the middle of here. Well, it's just going to be the middle of the first coordinates, the x's, and the middle of the y's. To find the middle of two numbers, there's a couple of ways you could do it, but the simplest way is just to average them out. So if I had the middle of 1 and 5, let's just write this up. If I wanted the middle of 1 and 5, say, I could just do 1 plus 5, which is 6, and then divide by 2, which is 3. And 3 is clearly the middle of 1 and 5. So I can just average out the x's and average out the y's. So as a formula, you get the following. Our midpoint formula would be x1 plus x2 divided by 2, the average of the x's, and then y1 plus y2 divided by 2, the average of the y's. Now you can remember this formula or just use your common sense that it is the average of x's and average of y's each time if you don't want to remember a full formula. Let's go into a few examples. Example 1 says, find the midpoint between 2, 6 and 8, 12. So our midpoint, I'll just write midpoint, is simply going to be the average of the x's, 2 plus 8 divided by 2, and the average of the y's, 6 plus 12 divided by 2. So there's our starting point. Work out our sums, 10 over 2 and 18 over 2. So our final answer, 10 divided by 2 is 5, and 18 divided by 2 is 9. So 5, 9 is the midpoint. And just a quick check, is 5 between the middle of 2 and 8, 5, 6, 7, 8, 2, 3, 4, 5, that's 3 away, so it's in the middle. And between 6 and 12 is 9, well, it's 3 away from 6 and 3 away from 12, so I'm done. I've definitely got my midpoint. Example 2 says find the midpoint between -4 and 6 and -3 and -9. This is where you just need to watch your negatives here. So your midpoint is simply just going to be the average of the x's, -4 plus -3 divided by 2, and the average of our y's, which is 6 plus -9 divided by 2. So watching out for these negatives. -4, take away 3 is -7, so I'll get -7 over 2. And 6 take away 9 is -3, so I get -3 over 2. Now they're both simplified fractions, so you could in theory just leave them as simplified fractions, or if you prefer decimals, 7 divided by 2 is 3.5, so -3.5, and 3 divided by 2 is 1.5, so -1.5. And there we go, our final answer. Example 3 says in the diagram, A, 9 minus 2 lies on the circumference of the circle with centre C, 17, 12, and the line AB is the diameter of the circle. Find the coordinates of B. So a little bit kind of working backwards here. I know this point, I know the middle, and I'm trying to find the point on the outside. So let's just take a few notes here. A is 9 minus 2, so I'll write that down there. And C is 17, 12, which I can write here. And I want to know the coordinates of this. Let's call that x2, y2. So we know that if we add 9 and x2 and divide by 2, we'll get 17. So we can work backwards to get our solution. So for our x's, so to get x2, we'll do 9 plus x2 divided by 2 equals the first coordinate of the middle, 17. So we can work backwards, and that means that 9 plus x2 must equal 2 times 17, which is 34. So our x2 is 34 minus 9. So our x coordinate is 25. Let's do the same with our y. So to get our y2, we know that minus 2, the y coordinate of A, plus our y2 divided by 2, remember, must equal the y coordinate of the middle, which is 12. 12 times 2 is 24, so we get minus 2 plus y2 equals 24. So y2 must be 24 plus 2, y2 is 26. So the coordinates of B equals 25, 26. Straight line, collinearity. So we're going to look at today what is collinearity. So if we look at these three things here, I can draw 3 points, and if I draw A, B, C here, and not in a straight line with each other, you can see that the gradient between A and B is clearly not the same as the gradient between B and C. But B is a common point, but we're not on a straight line, clearly. Or I could draw 4 points, A, B, C, and D, and make the gradient of A to B the same as the gradient of C to D. In other words, these lines are parallel because I've not got a point in common, they're separate lines. However, I could draw 3 points on a straight line, A, B, C, and clearly the gradient between any 2 points is the same. The gradient between A and B is the gradient between B and C. Essentially, A to B and B to C are parallel, but since B is a point in both lines, they must be on a straight line, so they're collinear. So B is a common point. So to prove something's collinear, you just check the gradient between 2 pairs of points, making sure that one point is a common point. And if the gradient is the same, they're collinear. And if they're not the same, they're not collinear. Nice and simple. So points which lie on the same straight line are called collinear. And that's just a definition. Example 1, show that the points P, Q, and R are collinear. So we just need to check the gradient between P and Q. Let's use the gradient formula. y2 minus y1 over x2 minus x1, where that would be x1 and y1, and this would be x2 and y2. So that is just 2 take away minus 1 over 0 take away minus 6. That gives me 3 over 6, which we can simplify down to a half. Let's do the same thing for Q to R. So if I change my colours here, if I call that x1 and y1 for Q and x2 and y2 for R, then the gradient between Q and R equals y2 minus y1, 6 minus 2 over 8 minus 0. 6 take away 2 is 4, 8 take away 0 is 8, that simplifies to a half. So I've shown it, but I need to say how I know now. So since the gradient of PQ equals the gradient of QR, PQ and R are collinear, as Q is a common point. Example 2 says these points A, B, and C are collinear. Find the value of K, which is here. So again, it's the same idea. Find the gradient between A to B and make it equal to the gradient between B and C. So our solution, since A, B, and C are collinear, then the gradient of A to B must equal the gradient of B to C. So the gradient of A to B is equal to K minus minus 1 over minus 1 take away 1, and the gradient of B to C is 7 minus K over 5 minus minus 1. And we just make them equal to each other. So we've got K plus 1 on the top, minus 1 minus 1 is minus 2, equals 7 minus K on the top, 5 minus minus 1 is 6. And these are nice and easy. You do this times this equals this times this. So that gives us 6 times K plus 1 equals minus 2 times 7 minus K. 6K plus 6 is minus 14 plus 2K. Moving the K's across, we get 4K plus 6 is minus 14. So 4K must be minus 20, which means K is minus 20 over 4. So K equals minus 5.
It's Collinear for Maths. Today we're going to be looking at the gradient of a straight line for higher maths. Essentially, we're going to be looking at how we can work out the gradient given the angle that a line makes with the x-axis and the positive direction of the x-axis as definition. So let's have a quick look at this. If I draw a straight line and call it x1, y1, one point, x2, y2 is another point, then clearly the horizontal is x2 minus x1 and the vertical would be y2 minus y1. So that's where the gradient formula comes from. Vertical over horizontal is defined as the gradient, or y2 minus y1 over x2 minus x1. But from our basic definition of the tan of an angle, if I define this angle as some angle, call it theta, the tan is the opposite over the adjacent. Well, opposite over adjacent would be y2 minus y1 over x2 minus x1, which is still the same formula for the gradient. So that means that the gradient must be equal to the tan of the angle, or tan theta. So that's exactly what our standard thing is for higher maths. Given the angle theta, the gradient is tan theta. Now this theta is this direction with the x-axis. We call that the positive direction. So it's not the angle over this side. It is the angle this side. The angle it makes with the positive direction of the x-axis. And you can work that out from either the x-axis itself or draw any horizontal line and it'll give you the same angle in there. Okay, example 1 says calculate the gradient of a straight line shown in this diagram. So we've got a simple diagram, a straight line, and we've got an angle of 32 degrees and we have to calculate the gradient. So we should be able to right away write down that the gradient equals the tan of the angle. So that's equal to the tan of 32 degrees. So we'll need to get a calculator and work that out. So our calculator tells us that the tan of 32 degrees is 0.625 to 3 decimal places. So our gradient is 0.625 to 3 decimal places. Example 2 says find the angle that the line P minus 2 and Q17 makes with the positive direction of the x-axis. What's it asking us? Well, if we draw ourselves a little picture, there's an x and y axis roughly. And we've got some line with two coordinates, a P and a Q, and it's asking us, what is this angle in here? Let's call that theta. So we already know that tan theta equals the gradient. So if we can find the gradient, we can work backwards to find the angle by using the inverse tan. So from our definition of gradient, y2 minus y1 over x2 minus x1. If we call that x1 and y1, this one would be x2 and y2. Watching our negatives here, that gives us 7 minus negative 2 on the top and 1 minus negative 2 on the bottom. That's 9 over 3, which is just 3 in total. So we now know that the tan of our angle is equal to the number 3. So we can use a calculator to do the inverse tan. So theta is the inverse tan of the number 3 in degrees is 71.6 degrees. The three significant figures. Example 3 says the line AB makes an angle of 60 degrees with the y-axis. Find the exact value of the gradient AB. So we've got a picture here again where the angle is the y-axis. Now that's not the gradient. Remember, gradient is the angle it makes with the x-axis. So I need to draw myself a little diagram here. If I draw a horizontal line, that's our theta in here. This angle, well, it's going to be 90 minus 60. That's going to be 30 degrees. We have to first work that out. We now know that since the gradient equals the tan of the angle theta, then our gradient is equal to the tan of 30 degrees and not the tan of 60 degrees. The tan of 30 degrees is an exact value. That is 1 over root 3. So our gradient is just 1 over the square root of 3 as an exact value. Quite often with this type of work at higher maths, you will have to use exact values, those being 30 degrees, 45 degrees, 60 degrees for tan. So make sure you know your exact values. Example 4 says find the size of angle theta shown in this diagram. And we have got the diagram here where theta, again, is on the y-axis. So it's a bit of a trick, but we can work out some other angle and it adds up to 90. So if I draw that in here, if I just draw a horizontal line across here, as best I can, we know that we can work out this angle here, let's call it alpha. And we would know that the tan of alpha in this case would be equal to the number 5. And then we can work out alpha, that is the inverse tan of 5. And that would equal 78.7 degrees. So since we know that that's 78.7, then theta must be 90 minus 78.7, which is 11.3 degrees. So just watch out for what angle they're giving you, what angle they're trying to make you work out. Okay, a little past paper question that actually uses this with some of the stuff that we've already learnt so far. So 2015 paper 1 question 9 says, ABC are points such that AB is parallel with the line with equation this, and BC makes an angle of 150 degrees with the positive direction of the x-axis. Is it collinear or not? So it's a collinear question, but it's using this idea that the tan of an angle makes the gradient. So that's the first thing. We need to work out our gradient. So let's look at the first line. We've got y plus root 3x equals 0. If they're collinear, the gradients of any bits will be the same. So rearranging this, y is minus root 3x. The gradient of this part, AB, is equal to minus root 3. We've done the first part, we know our first gradient. The second part says, and BC makes an angle of 150 degrees. So looking at the gradient of BC, we've got the tan of 150 degrees is equal to our gradient. Now, 150 degrees is not an exact value, but it is related to an exact value. So if we draw a cast diagram, then that's 180 minus, 180 plus our angle, and 360 minus. If we look at this one here, 180 minus 150 is 30, so it's related in that point. So if we work out the tan of 30, well, the tan of 30 degrees is an exact value, 1 over root 3. So that means that because of the relatedness angle, if it was in this quadrant, 180 minus 150 would be 30. The tan here is negative, so the tan of 150 degrees is minus 1 over root 3. We've now worked out our gradients. We know the gradient of the bit AB is minus root 3 and the gradient of 150 degrees is minus 1 over root 3. So these are not parallel lines because they are not got the same gradient. So we could just write a little statement. The gradient of AB does not equal the gradient of BC. Therefore, the lines are not parallel and therefore not collinear. And we're done there. Mr. Clare here for Clare Maths. Today we're going to be looking at perpendicular gradients. We're going to see how if you take two lines which are at right angles to each other, then the gradients times together to give minus 1. We've got a couple of lines here at right angles to each other. So the theorem is, if you times the two gradients together and you get the answer minus 1, then you can say that the lines are perpendicular. They are at right angles to each other. Or, conversely, you can say that if you know that two lines are perpendicular, then the lines times together to give minus 1. Now, you might be wondering, why is that the case? So looking at this app here, you can see I've drawn two lines, and the gradient of the first line is 1 over 9, a ninth. But if you take the gradient of the other line, you can see that the gradient is minus 9 over 1, or minus 9. Those two lines are at right angles to each other. It should be obvious that they are from looking at it. And that doesn't matter how much you rotate this line round. If I pick a different line, let's say here, the gradient of that line is 1/3, but the other line going sloping down the way is minus 3. Minus 3 times a third is minus 1. That's a good one. If you look at these, you can see the gradient of the line sloping up the way is 5.5 over 10.99. The gradient of the line sloping down the way is minus 10.99 over 5.5. So essentially these are called the negative reciprocals of each other, and they're quite easy to find. Let's have a look though, first of all, at vertical and horizontal lines. The problem with these ones is a gradient of a horizontal line is just 0. So the gradient of this line is just 0. But if we take the gradient of the vertical line, well, that's undefined. So that's, I suppose, the one time when it doesn't work, because you can't, undefined times 0 is not minus 1. But you should know vertical and horizontal are at right angles anyway. What do I mean by that? So let's say example 1, if the gradient of the first line, let's call it AB, is equal to 3, how do I know the gradient of CD at right angles to that? Well, we say it's a negative reciprocal. All you have to do, 3 becomes a third and minus a third. If you times them together, you get minus 1. Let's take a different example. If I had MAB was equal to negative 4, then the gradient of CD, nice and easy, is going to be a quarter. Again, that's now not going to be negative because the first one's already negative. If we start off with a fraction, let's say the gradient of AB was equal to a half, then the gradient of CD, a half becomes 2, and minus 2. These are called the negative reciprocals of each other. You times them together, you always get minus 1. Do one last example. If I had the gradient of AB, let's take a harder fraction, was 3/4 this time. The easiest way to get the gradient of the other one, if they're at right angles, is flip the fraction upside down, in other words, a reciprocal, and put a minus in front. If there's already a minus in the first one, you can put a minus in the second one. So example 1 says, given that t is the point 1 minus 2, and s is the point minus 4, 5, find the gradient of a line perpendicular to ST. So our starting point is, let's find the gradient of ST. Well, that's just 5 minus 2, y2 minus y1, over minus 4 minus 1, x2 minus x1. So that gives me 7 over minus 5. And since they're perpendicular, I can just draw that. Then gradient of the first one times the gradient of the second one must equal minus 1. Therefore, the gradient of the perpendicular line is equal to 5 over 7. Let's flip that upside down and put a minus in front of that, but it's already got a minus, so it becomes a plus. And we're done. Okay, question 2 says triangle MOP has vertices minus 3, 9, 0, 0, and 12, 4. Show that the triangle is right angled. So we could draw a kind of picture of this just as a kind of rough sketch at the side. Nowhere near accurate, but minus 3, 9 would be up here somewhere, so let's call that M. There's a 0, 0. And 12, along 12 and up 4, maybe somewhere around about here. So there's your O and there's your P. We can see here you end up with a triangle. We're not sure if it's right angled or not until we prove it. Now to prove it, we just need to check the gradients of each bits and see if any two make a right angle. We would hope that it's going to be MO and OP. So let's check the gradient of MO. Gradient of MO is 0 minus 9 over 0 minus minus 3. That's minus 9 over 3, which is minus 3. So we've got our first gradient. Let's check the gradient now of OP. So O to P, that's going to be 4 minus 0 over 12 minus 0. That's 4 12s. We'll simplify that to 1/3. And just to be on the safe side, let's check our last gradient. The gradient from M to P. That's going to be 4 minus 9. And it's going to be 12 minus minus 3. 4 minus 9 is negative 5 over 15. That's minus 1/3. And we can then say that since we always have to write this little statement, M1 times M2 equals minus 1. Let's just check which two times together to make minus 1. Well, we've got 1/3. And flip that upside down, you get 3 and put a minus front, minus 3. So these two, MO and OP, are perpendicular. And therefore we can say that the triangle MOP is right angled. Let's clear here for clear maths. In the last video we looked at the gradients of two lines which are perpendicular, and we found out that if you times the gradients together you get the answer of -1, which allows you to find the gradient of one of the lines given the gradient of the other, or if you can work them out. We'll now look at some specific lines. The first one we're going to look at is a perpendicular bisector. What that is defined as is essentially this. If you take any line, let's call it A and B, and we draw another line at right angles, if it cuts it in half, it is called a perpendicular bisector. So it cuts it in half at right angles. That would happen in, say, an isosceles triangle or an equilateral triangle, for instance. And we'll look at a few practical examples of this. A is the point -2, 1. B is the point 4, 7. Find the equation of the perpendicular bisector of AB. So step 1, we're going to have to find the gradient of AB. So our gradient of AB, very easy, is 7 minus 1 over 4 minus minus 2. That's 6 over 6, which is 1. Nice and simple. So since we know that that is 1, we can automatically know the gradient of the perpendicular. So therefore, the gradient of our perpendicular line is going to be -1. And we always need to write the statement. Look at the previous video if you're not sure. Since M1 times M2 equals -1. So we now know our gradient is -1. That's first step. Now remember, perpendicular bisector is a line that cuts it in half. So we need the midpoint of A and B as well. So the midpoint of A and B, remember we can do that by adding up the x's. So 4 minus 2. And taking the average, divide by 2. And then the y's, 7 plus 1, also divided by 2. So that's 4 minus 2, which is 2 over 2. 7 plus 1 is 8 over 2. Our midpoint is equal to 1, 4. We've got two bits of information that we need. We've got our gradient and we've got a point. If we've got a gradient and a point, we can always find the equation of a straight line using y minus b equals mx minus a, or if you prefer, y equals mx plus c, whatever method is best for you. I always use y minus b equals mx minus a. So our point, I'll just write it nice and neatly, is 1, 4, and our gradient is equal to -1. There's my a and there's my b. So y minus b equals mx minus a. So we've got y minus 4 is -1, x minus 1. So y minus 4 is minus x plus 1, or to put it in a nicer way, y equals minus x, take the 4 across, plus 5. There's the gradient, there's this equation of our perpendicular bisector. Okay, here's a little question from 2017 paper 2, so it's a calculator question. It was just question 1, and it's part A and B. There was a part C, but I've not got that far yet. So triangle ABC is shown in the diagram below. The coordinates of B are 3, 0, and the coordinates of C are 9, negative 2, and the broken line is the perpendicular bisector of BC. Part A, find the equation of the perpendicular bisector of BC. So, we're going to need this point here, which is our midpoint, and we're going to need the gradient. Let's start off with the gradient. So 3, 0, 9 minus 2. Let's write that here so we can see it. So part A, the gradient of BC is equal to minus 2 take away 0 over 9 minus 3 minus 2 over 6, which is negative a third. So then we can immediately remember, say, that the gradient of the perpendicular equals negative reciprocal. So I take the 3 up and then put a minus in front, but it's already got a minus, so it's just 3. And we need to say since m1 times m2 equals minus 1. So we've got our gradient. We now need the midpoint. So the midpoint of BC is equal to the average of the x's, 3 plus 9 divided by 2, and the average of the y's, 0 minus 2 divided by 2. 3 plus 9 is 12, divided by 2 is 6. 0 minus 2 is negative 2, divided by 2 is negative 1. We've now got all the information we need to find the equation of the line. We've got a gradient, and we've got a point. So using y minus b equals mx minus a, call that A, call that B. Y minus 1 is equal to 3x minus 6. Y plus 1 is 3x minus 18. Or to put it a nicer way, y equals 3x minus 19. So that was part A of the question. Let's see what part B was asking for. So that's everything on perpendicular bisectors. It says the line AB makes an angle of 45 degrees with the positive direction of the x-axis. Find the equation of AB. Let's have a look at that then. We need to use the fact that the gradient equals the tan of the angle, which if you watch one of our previous videos on that, on gradient, you'll see we've done that before. So our gradient of the line is called AB equals the tan of 45 degrees. Now remember, this was a calculator paper, paper 2, so you could just use your calculator to work that out, but it is an exact value as well. Let's have a look at the tan of 45 as an exact value just to be safe. If I draw a right angle triangle and I want a 45 degree angle, then both of these are 45, which means it must be isosceles, so it's 1, 1. Using Pythagoras, I would get root 2. The tan of 45, even without a calculator, it's just opposite over adjacent, it's 1. So we know our gradient and we need a point. So what point are we going to use? AB. Well, we've already got B. B is 3, 0. So our point, B equals 3, 0. We've now got 2 bits of information. So you can use y minus b equals mx minus a if you want. Call that A and B. Or you can use y equals mx plus c. So y minus 0 equals 1, x minus 3. So y equals x minus 3 is the equation of our straight line.
Mr. Clown here from Clown Maths. Today we're going to be looking at higher maths again and some altitudes. So we need to define what an altitude is, and then we're going to try and find how to find the equation of an altitude. So I've drawn a couple of triangles. I've drawn a right angle triangle, and previously when we did right angle triangles, you would be remembering that the area of a triangle is a half the base times the height. But it's not actually just any old height, it's the vertical height. The vertical height is of a right angle triangle would be called the altitude of the triangle because it is a line that hits the base at right angles. Technically, if you take any triangle, looking over here, a non-right angle triangle, it would still be half the base times height for the area, or we could say it's half the base times the altitude. So an altitude is basically the height of a triangle. Let's be more formal about that. The altitude of a triangle is a line drawn from one vertex which meets the opposite side at right angles. So the word vertex is just the corner of the triangle. So if I go to any corner and draw a straight line down hitting the opposite side at right angles, that line is called an altitude. I could draw another line from here to here hitting at right angles, and that would be an altitude, and another line from here to here. One thing to note is an altitude often does not hit the other side and cuts it in half. It does not cut it in half. It would only cut it in half if it was an isosceles triangle or an equilateral triangle. So bear that in mind. If you go back to my previous video on perpendicular bisectors, you will start to realize that a perpendicular bisector is a special type of altitude. It's an altitude that cuts a line in half. It's also therefore called a median, which we will get to in the next video. So if I draw a triangle ABC, and I want to say I want the altitude from C, I'm just literally saying look at vertex C and draw a line straight down at right angles. If it cuts it at right angles, that's the altitude from C. If I wanted the altitude from A, I'd go from A straight across, cutting the opposite side at right angles. And similarly from B, straight across, cutting the opposite side at right angles. Now, we're going to be looking at the equation of an altitude. If you want the equation of any straight line, you need two things. You need a point and you need the gradient of the line. Now, since the altitude cuts at right angles, if you knew the gradient of line A and B, then using negative reciprocals, the rule that m1 times m2 equals -1 would tell you the gradient straight away of the altitude. And then you've already got a point, assuming you've got all the points of a triangle, you would then use point C to find the equation of the altitude. And that's what we're going to look at now with an example. Example 1 says triangle ABC has vertices A 3 minus 5, B 4, 3, and C minus 7, 2. Find the equation of the altitude from A. I always find it handy just to draw a simple sketch of this so that you understand what's going on. So if I just draw a random triangle, I'm not even going to try and plot it properly, just a really quick sketch at the side, just like so. If I just call the first one A, the second one B, and the third one C. It says the equation of the altitude from A, so if I call that A and go across, meeting that line at right angles. So remember, we always need two things to find the equation of a line. We need the gradient and we need a point. Now, to find the gradient of a line, you need 2 points usually, but we don't have this point. It doesn't cut it in half, but we do have B and C. So we can find the gradient of B and C and use the fact that it's perpendicular to find the gradient of the altitude. So let's start doing that. The gradient of BC is equal to, well, 2 minus 3 over minus 7 minus 4. 2 minus 3 is -1. Minus 7 minus 4 is minus 11, or simplify that to just the 1 over 11. So we know we're going to BC, and since it's an altitude, therefore, the gradient of the perpendicular equals -11 because of nice symptoms. And we always need to write our little statement since m1 times m2 must equal -1. So we've now got our gradient. Let's just highlight that with a red mark. So that's what we need. We now need also the point and use y minus b equals mx minus a. So with point, remember we're using this point A, which is 3 minus 5. So using point A, which is 3 minus 5, and our gradient, which is -11, y minus b equals mx minus a. Well, that's the point A and that's the point B. Y minus -5, watch out for your double minuses, equals -11 x minus 3. Simplify that a little bit, so we've got y plus 5 is -11x plus 33, or to take the 5 over to the other side, we get -11x plus 28. We've now got the equation of our altitude. Okay, a little past paper question, 2015 paper 2, just question 1A. You'll notice that most of these questions have 3 parts. You'll find the equation of various things. Once we get to the end of this course, we'll bring it all together and we'll show all 3 parts together. But for now, we'll just do part A. The vertices of the triangle ABC are minus 5, 7, minus 1, minus 5, and 13, 3 as shown in the diagram. The broken line represents the altitude from C. Show that the equation of the altitude from C is x minus 3y equals 4. So they're telling us what the equation is going to be, but we're just going to work it out and see if we get the same answer. So from C, we need the gradient. So we're going to have to find the gradient of A and B and use perpendicular lines. And then we're going to use point C with y minus b equals mx minus a. So the gradient of A and B, well, we've got b is minus 5, minus 7 on the top, and minus 1, minus 5 on the bottom. Minus 5 take away 7 is negative 12. Minus 1 plus 5 is 4. Minus 12 divided by 4 is minus 3 or negative 3. So that means we immediately know, therefore, the gradient of the perpendicular equals a third. Look back at my previous videos on perpendicular gradients if you want to know how to do that, but that's because since m1 times m2 equals minus 1. And we always need to write that statement to get our marks, remember. So we've got our gradient and we've got our point. If we just double check our question, our point, remember, is the one from the vertex C. So that's 13.3 is what we're using. So using the point C, which is 13.3, and our gradient M, which is 1/3, then we do y minus b is mx minus a. Y minus 3 is 1/3 of x minus 13. Now, if we go back to the question, you'll see that it's not written in the form y equals mx plus c. It's written as x minus 3y equals 4. So we're eliminating fractions here, which we'd normally do anyway. So to eliminate a fraction, we can just times this whole side by 3, and that will leave 1 of this side. So let's just do that. 3 bracket y minus 3, remember your bracket, equals 1 x minus 13. Multiplying out our bracket, we get 3y minus 9 is x minus 13. And then moving everything to the left-hand side. Was it the number as well? Nope, except the numbers. So we want all the numbers on the right and the letters on the left. So we've got 3y minus x is equal to, well, minus 13 plus 9 is minus 4. Now that is close to what they've got, but they've got positive 4. You might be thinking you've made a mistake here. No, it's just that they've moved everything over to opposite sides. And I always have times everything by minus 1. So we can, as long as you've got your x, your 3, and your 4, you've probably done it correctly. So let's just tidy that up to make it 4. So last step, that's going to be minus 3y plus x equals 4. Just moving everything over to the opposite sides, or to make it look the way they did, x minus 3y equals 4 as required.
Mr. Clown here for Clown Maths. Today we're going to be looking at medians in a triangle and how to find the equation of a median of a triangle. So what is a median? Well, a median of a triangle is just a line which joins a vertex to the midpoint of the opposite line. Now, if you look at one of my previous videos, you'll see that we've already worked out how to do the midpoint formula of a line. So it's the same as usual. We're trying to find the equation of a line. So we need the point, which is going to be a midpoint. And then we need the gradient. And once we've got the midpoint, then we'll have 2 points, the gradient and the opposite vertex. So we can find the gradient and use the straight line formula, y minus b equals mx minus a, to find the equation of that median. First example says triangle ABC has vertices 4 minus 9, 10, 2, and 4 minus 4. Find the equation of the median from A. So I might as well just draw a triangle to see what I'm looking at. It doesn't have to be exact, it doesn't have to be accurate, it can just be any old triangle, just to give me an idea. Let's just call that A, this is B, and this is C. It says the median from A, so if I draw a line from A, we know that that's going to cut this opposite line in half right there. Let's call that point that it joins that line at, let's call it M, just to give us a reference point, M being midpoint. So the first thing we need to do is find the equation of M. So to find M, it is going to be using the midpoint formula. So we've got B is 10 and then C is 4. So 10 plus 4 divided by 2. And then for the Y parts, we've got 2. And for C, we've got minus 4 divided by 2 as well. 10 plus 4 is 14 divided by 2. 2 minus 4 is negative 2 divided by 2. So our midpoint is just the point 7 and negative 1. So there's our first information. We now we've got a point. We've already had a point A anyway, but we need the gradient. We've got 2 points to find the gradient between A and M. So if I write this as the gradient between A and M, well, remember A is 4 minus 9. So we've got minus 9 minus minus 1, y2 minus y1, over x2, that's 4 minus 7. Or alternatively, you could have went the other way, minus 1 take away minus 9, 7 take away 4. It makes no difference really. Minus 9 add 1 is minus 8. 4 take away 7 is negative 3. So that's just 8/3. We've now got our gradient. So now we can do y minus b equals mx minus a. Using either the point that we found out is the midpoint or the vertex. I'll use the midpoint, so that's going to be my a and b. So I've got y minus minus 1 equals 8/3 x minus 7. Multiplying through by 3, we get 3 bracket y plus 1 because of the minus minus equals 8 bracket x minus 7. And then just tidying that up, 3y plus 3 equals 8x minus 56. I'll just take everything over to the left hand side in this case and make it equal to 0. So we've got minus 8x plus 3y. 3 plus 56 is 59, and that equals 0. So that's one form you could leave it in. Or if you preferred another form, you could have said that 3y plus 8x equals minus 59. That's another option. Example from the 2015 paper 2 question 1b. I'm not going to do part A, I've done that in a previous video, but I'm just going to focus on part B. Then later on we'll tie this all together and we'll see how A, B and C go together. So just looking at this part of the question here, find the equation of the median from B. So there's my B here. It's not got a line, so I'm just going to draw one in. It's asking me to find the equation of this line where it cuts this in half. So let's just call that M again. So we can find our midpoint. So to find M, we're looking at 2 points. We're looking at A and C because it's between A and C. So it's minus 5 add 13 divided by 2. And it's 7 plus 3, also divided by 2. 13 minus 5 is 8. So that's 8 over 2. And it's 10 over 2. So that is 4 and 5. There's our midpoint. We now need our gradient, because we always need a gradient and a point. So it's a gradient between B and M. So the gradient between B and M equals, well, we need y2 minus y1. So B is minus 1 minus 5. So 5 minus minus 5 over 4 minus, being very careful, it's minus 1. So minus 1. 5 minus negative 5 is 10. 4 minus negative 1 is 5. So our gradient is a nice round number of 2. We've now got a gradient and a point. So we can use y minus b equals m, x minus a. Y minus 5 equals 2, x minus 4. Using our point m that we just found out as our a and b. Y minus 5 then is 2x minus 8. Or to put it in the normal straight line format, y equals 2x minus 8 plus 5 is minus 3. We've now got the equation of our median, and we're done. Mr. Collinear here from Collinear Maths. Today we're going to be looking at higher maths, and we're on a straight line still. We're almost at the end. We're looking at the point of intersection between two lines. So what I mean by that is if you have two lines like an altitude, maybe of a triangle and a median meeting together, what is the coordinates of that point? Well, let's have a look at this on a diagram here. So we've got a triangle drawn. So a reminder what a median is. A median from A would be the line that goes from A and cuts the opposite line in half, not necessarily at right angles. The altitude from B would be the line that goes from B and cuts the opposite line at right angles, but not necessarily in half. Obviously, if it did both, it would be a perpendicular bisector, and we'd be looking at the point of intersection, the point where the two lines meet. If you want to find the point of intersection between two lines, you've got two equations. If you solve them simultaneously, you will find the point of intersection because the point will work for both lines. So that's exactly what we're going to do. To calculate the point of intersection, we're going to solve simultaneous equations. Now that could be by substitution, it could be simultaneous equations by elimination. It could even be graphical, but not usually at higher. So we'll usually look at substitution or elimination. At National 5 Maths, you solve simultaneous equations quite often by elimination, where you set them up in two, one above the other, and then you scale them and eliminate x or y by adding or taking away. At higher, more often than not, we'll do it by substitution, where you'll have y equals something, you'll also have y equals something, which means both the sides will be equal to each other. Let's look at a few examples like that. Okay, our example says triangle PQR has vertices P, 8, 3, Q minus 1, 6, and R2, 3. And if to find the equation of the altitude, a median, and the coordinates of M, which is the point of intersection, as you can see on the diagram. So let's take a note of some of our points, 8, 3, and then R is 2, 3, and Q is up here at minus 1, 6. Obviously, not a very accurate diagram, but that is okay. It's accurate enough where we can see that this is a horizontal line. Let's hope it is. Now, we can tell straight away it's a horizontal line just by looking at the coordinates. Notice the y coordinate is the same in each. So since the y is the same in each, it must be a horizontal line because y is equal to 3 in each case. But we can work out our gradient anyway. So let's start off with part A, find the equation of the altitude of QS. So we need the gradient between R and P. So let's work that out. Part A, the gradient between R and P. We'll just use the gradient formula anyway. 3 minus 3, which you can see is 0 straight away. 8 minus 2, 0 over 6, which is 0. So therefore, the gradient of QTS, which is our right angles, which is perpendicular, equals undefined in this case. Usually it's m1 times n2 equals minus 1, but a horizontal 0, a vertical line is undefined. Therefore, the equation of QS is, put it in a little box, a vertical line has an equation of x equals a number. X equals, well, the only number we've got is Q is minus 1, so it's minus 1. Find the equation of the median RT. So we need the midpoint of, well, the Q and P. Just keeping our wits about us, the median is this way, the midpoint of these two. So that's minus 1 plus 8 divided by 2 and 6 plus 3 divided by 2. That's going to give us some fractions. It's going to give us 7 over 2 and 9 over 2. But let's make them whole numbers. Well, not whole numbers, decimal numbers. 3.5 and 4.5. Just because it will be easier to see the gradient in a minute. So we're now going to need the gradient between R and our midpoint, which is called T. So the gradient of R to T is going to be 4.5 minus 3 over 3.5 minus 2. Well, that is 1.5 on the top, and it's also 1.5 on the bottom, so luckily our gradient is just 1. So now we can use y minus b equals mx minus a, and we might as well just use the whole number ones, 2 and 3. So using the points 2 and 3 as our a and b, then y minus 3 equals 1, x minus 2. So y minus 3 equals x minus 2, or y equals x minus 2 plus 3. is 1. Hence, find the coordinates of M, which remember was our point of intersection for these two lines. So there's our two lines equations written out again. We know that x is minus 1, so we can just substitute it into y. Since x is minus 1, then y equals minus 1 plus 1, which is 0. So our point is very simple, in this case, minus 1, 0. And we're done. Okay, 2017 paper 2 question 1 says triangle ABC is shown in the diagram. The coordinates of B are 3, 0. Let's just note that there. The coordinates of C are 9, minus 2. And the broken line is a perpendicular bisector of BC. Part A, find the equation of the perpendicular bisector. So part A, for a perpendicular bisector, we need the gradient and we need the midpoint. So let's start off with the midpoint of B and C. So that's 3 plus 9 divided by 2. And it's also 0 minus 2 divided by 2. 3 plus 9 is 12, divided by 2 is 6. Minus 2 divided by 2 is minus 1. So we've got our midpoint. There it is there. And then we need the gradient. So the gradient of BC is equal to minus 2 take away 0 on the top and 9 take away 3 on the bottom. That's minus 2 over 6, which is minus a third. Therefore, the gradient of our perpendicular is going to be 3, since they are perpendicular, so m1 times m2 equals minus 1. You always need to write that little statement. So we've now got both of our things. We've got our gradient, which is here, and we've got our point, so we can use y minus b equals mx minus a. So y minus minus 1, because that's a and b, equals mx minus 6. So y plus 1 is 3x minus 18. So y equals 3x minus 19. Part A done. Part B says the line AB makes an angle of 45 degrees with the positive direction of the x-axis. Find the equation of AB. So remember from previous, gradient is equal to tan theta, assuming that theta is the positive direction of the x-axis. So our gradient is equal to the tan of 45 degrees, which is an exact value, but I'll remind you of that exact value by drawing a triangle out for you. If I draw a right angle triangle and make that side 1 and 1, it's isosceles, which means that these 45 degrees are here. 1 squared plus 1 squared is 2, so it's the square root of 2 on the hypotenuse. You don't actually need that. You can clearly see the tan of 45 is 1, opposite over adjacent. So our gradient is just equal to 1. We now need to find the equation of AB. Let's have a look. So we've got A to B. B is 3, 0. So we've got a point and we've got a gradient. So we're fine. Our point B equals 3, 0. Y minus B equals mx minus A. In other words, y equals x, take away 3. Copied and pasted the two equations we've just found out, because part C says find the coordinates of the point of intersection of AB and the perpendicular bisector of BC. These are our two equations that we just found out for both of those things. Notice they both say y equals. So if we both say y equals, we're solving simultaneously, the y is the same for both of them. So we can just make the right hand sides equal to each other. Alternatively, we could take away the two equations from each other. But I'm going to do it this way because it's much simpler. If I just write 3x minus 19, that equals y. So that equals x minus 3. As long as we both say y equals, you can always do that. So solving that equation, taking the x across to the other side, you get 2x equaling, taking the 19 over, 19 take away 3 is 16. So x equals 8. We've got an x, we now need a y. Our easiest y equation is the bottom one, so we'll just use that. Y equals 8, take away 3, which is 5. We now need to actually write down the point of intersection. Our answer is 8, 5. Don't underline it, score it, whatever you want. We're done. 2019, paper 2, question 1. Triangle ABC has these vertices. It has a lot of lines drawn on it, but it's just trying to show us what the lines are. So it says, find the equation of a median BD. So we're saying that this is cutting the opposite line in half, so we could show that on our diagram just to help us. Then it says find the equation of the altitude AE, so there's your right angle there. We could note our points if we want, if it helps us to see it. -5, 12, 11, -8. And the last one is -3, 6. So we'll do this in turn. Find the equation of a median BD. Median means we need the midpoint. So the midpoint of A and C, because it's going from B. So the middle of AC is equal to -5 plus -3 divided by 2 and -12 plus 6 divided by 2. That's -8 over 2 and it's -6 over 2, which is equal to -4 -3. There's our key point. We've got our midpoint. We now need to work out the gradient of our median. Now notice a lot of people make this mistake. Do not work out the gradient of this line when you're doing medians. That's not going to help us. We want the gradient of the line we're actually doing. We want to work out the gradient of the other line when we're doing perpendicular. So it's not perpendicular, so it's the gradient of BD. So we want the gradient of B to D, D being our midpoint. So we've got y2 minus y1, so let's just start with 8 minus 3 minus 8 minus -3 all over 11 minus -4. -8 add 3 is -5. 11 add 4 is 15. Simplify our fractions to get -1/3. We've now got our gradient, so we can use y minus b equals m x minus a. Any of the 2 points you want, either B or D. I'll just use the one that I can see. So I'm going to call that our A and that our B. Y minus -3 equals -1/3 x minus -4. Multiplying through by 3, we get 3 bracket y plus 3 minus -3 equals -1 x plus 4. Or 3y plus 9 equals -x minus 4. Or 3y plus x equals, taking the 9 over to the side, -13. And there's part A done. Part B says find the equation of the altitude AE. So I've made a point up called E, that's irrelevant. We want the equation of the altitude from A. So drawing a little sketch, I can't remember even if it looks the same as this. I just want to get an A, B and C here. So I'm realising that if I draw that down, it is the gradient of BC I need to find the perpendicular of the altitude. And I've called this point E. So starting off with the gradient of B to C, that equals 6 minus -8. I have to take a note of them up here. All over -3 minus 11. 6 add 8 is 14. -3 take away 11 is -14. So that's -1. Therefore, the gradient of ATE is equal to just 1, since m1 times m2 equals -1. We can now use y minus b equals mx minus a with the point A. So we've got our gradient. Our point A is -5, 12. Just take a note of that for us. And that's going to be our A and B. So y minus -12 equals 1 x minus -5. And I've underlined that. I should have underlined the 1. Bit silly there. So y plus 12 is equal to x plus 5. Or to put that a nicer way, y equals x. 5 take away 12 is -7. Okay, find the coordinates of the point of intersection between BD and AD. Now, I've deliberately made it so that my two equations look different just to show you something. You cannot immediately take these away or add them. You can, but you want everything over the same side of each equation before you do that. So you've got two options. You make them both y equals or x equals. Or if it's ever in this situation where you've got a multiple of y, you might as well make the bottom one move to the left-hand side, the y's and x's, so you've just got equals a number. So I'm just going to do that now. So your top one just stays as 3y plus x is minus 13, but your bottom one becomes y, taking the x across as minus x equals minus 7. And now you're in this kind of National 5 type simultaneous equation. So it's nice and easy to solve. I'm just going to add the equations together to get 4y equals minus 13 add minus 7 is minus 20. And therefore y is equal to minus 5. Once we get our y, we can get our x. So easiest one is y equals x minus 7. So y equals x minus 7. So minus 5 equals x minus 7. Or x, well, I'll put it this way. Add 7. 7 minus 5 is 2. 2 equals x. Or to put it another way, x equals 2. So our point of intersection is 2 minus 5. And we're done there. All the past paper questions. This will cover, of course, perpendicular lines, parallel lines, gradient equals tan theta, altitudes, medians, perpendicular bisectors, anything else you can think of. Let's go straight ahead into this. SQA Higher Maths 2015, paper 1, question 9. ABC are points such that AB is parallel to the line with equation y plus root 3x equals 0, and BC makes an angle of 150 degrees with the positive direction of the x-axis. Are they collinear? So you need to know what collinear means. They are all in a straight line. So if you work out if A to B are parallel and B to C are parallel, and when it says B is a point in common, they would be in a straight line because they're parallel or not. So let's just work on this. So the first part is to work out the gradient of AB. So for A to B, we have got y equals minus root 3x. So the gradient of that section is just minus root 3. For B to C, well, gradient equals tan theta because we've got the angle 150 degrees. So our gradient is equal to the tan of 150. Now, 150 is going to be an exact value. If you've got a cast diagram, we can see it's related to 180 minus 150. So if I work out the tan of 30 degrees is 1 over root 3. But 30 degrees is positive here and here. So that's 180 plus 30, which is 210. And that's 180 minus 30, which is 150. Here, tan is negative, so the tan of 150 is minus 1 over root 3. And then we can just make a little statement. Since the gradient of AB doesn't equal the gradient of BC, the points are not parallel. And so they're not collinear. Not parallel, so not collinear. Now, if they were equal, you would then say they are parallel, but since B is a common point, they're collinear. SQA National 5 Maths 2016, paper 1, question 11. Find the equation of a line passing through minus 2, 3, which is parallel to the line with equation y plus 4x equals 7. So parallel means same gradient. So I need the gradient and a point to work out an equation of a straight line. So let's work on the gradient first. So y equals minus 4x plus 7. So our gradient is minus 4 because it's parallel. Gradients are the same. Now we'll use y minus b equals mx minus a. And there's our point A and B. So we've got y minus 3 minus 4x minus minus 2. Okay. And then we can just work that out. Y minus 3 is minus 4x. 4 times 2 is 8, so it's minus 8. So y equals minus 4x minus 8. Add 3 is minus 5. SQA Higher Maths 2017 Paper 1 Question 11. A and B are points V's here. AB is parallel to this line. Find the value of A. So parallel means same gradient. So if we look at 3y minus 2x equals 4, that means that 3y equals 2x plus 4. So y is equal to 2/3 of x plus 4/3. Key point is our gradient is equal to 2/3 because it's parallel to this line. And then we've got our points here, but we know if we use the gradient formula on that, we need to get an answer of 2/3. So y2 minus y1 over x2 minus x1. So I'm going to do a take away 2 on the top and 5 take away minus 7 on the bottom, but that equals 2/3. Save it. 3 times a minus 2 equals 2 times 12. So 3a minus 6 is equal to 24. Nice and simple to solve. We get 30 and a is 10 for our final mark. SQA Higher Maths 2019 Paper 1 Question 7 had this one. The line makes a 30 degrees angle with opposite direction of the x-axis. Find the equation of the line perpendicular to it passing through 0 minus 4. So looking at the line L, the gradient is equal to the tan of 30. So the gradient of that is 1 over root 3 because it's an exact value. Now we can work out the gradient of our perpendicular. So the gradient of our perpendicular is equal to minus root 3 since m1 times m2 equals minus 1 because of perpendicular gradients. And then we can use our point. So I'll call that A and B. Y minus 4 equals minus root 3 x minus 0. Y plus 4 equals minus root 3x. Or y equals minus root 3x take away 4 would be fine as well. And we're done there.
SQA Higher Maths 2021 Paper 1 Question 4 on straight line. Determine whether the line passing through minus 4, 2 and 2 minus 7 is perpendicular to a line with equation 3y equals 2x plus 9. So to answer this question, I need to find the gradient between the 2 points and then check if m1 times m2 equals minus 1. So let's look at the gradient. So we've got x1 and y1, x2 and y2. Our gradient, remember, from National 5 Maths is y2 minus y1 over x2 minus x1. So let's look at that. That's minus 7 minus 2 on the top. And it's 2 minus minus 4. Watch out for that double minus. That's minus 9 on the top and 2 plus 4 is 6. Always simplify your fractions. Divide by 3 to get minus 3 over 2. So there's the gradient of our first line. Let's call that m1. And then looking at this line, we want to know the gradient of this one. So looking at m2, well, we know that 3y equals 2x plus 9. To find the gradient of this line, we need to have it in the form y equals mx plus c. So we'll just divide each side by 3. So that means that y is equal to 2/3 of x. 9 divided by 3 is 3. So m2 is equal to 2/3. So now we just check what is m1 times m2. Well, m1 is minus 3 over 2 times m2 is 2/3. Simplify in advance or after the fact, I'll just do it after the fact. Minus 3 times 2 is minus 6. 2 times 3 is 6. That gives minus 1. And then you need to write a little statement. Since m1 times m2 is minus 1, the lines are perpendicular. Since m1 times m2 equals minus 1, that implies the lines are perpendicular. And we're done there.
So Higher Maths 2022, Paper 1, Question 1. Determine the equation of a line perpendicular to 5x plus 2y equals 7, passing through minus 1, 6. Perpendicular, which means the gradients multiply together to give minus 1. So for gradient of this line, we've got 2y equals minus 5x plus 7. So y is minus 5 over 2, x plus 7 over 2. The gradient of this line is minus 5 over 2. So the gradient of our perpendicular line is equal to 2/5, since m1 times m2 equals minus 1. 2/5 of minus 5 over 2 gives us 2 marks already. Then we can just do the equation of a straight line. Y minus b equals mx minus a. Minus 1 is plus 1. So 5y minus 6, you might do, is 2x plus 1. Expanding our brackets, we get 5y minus 30 is 2x plus 2. So I'll leave it with 5y is equal to 2x. 2 plus 30 is 32. And you can leave it in any form you want. Y equals mx plus c. And multiples of y equals a multiple of x plus a multiple of a number. Whatever you want, really. So 5y minus 2x equals 32. And you can just leave it like that, or in any other correct form for the equation of a straight line. SQA Higher Maths 2017, Paper 2, Question 1 had this one. It's your standard, you've got a triangle, the coordinates of B are 3, 0, C are 9, minus 2. So I'll just write these as we go. And the broken line is the perpendicular bisector of BC. Find the equation of a perpendicular bisector. So a perpendicular bisector cuts a line in half at right angles. So I can find the midpoint using the midpoint formula and then go from there. So for part A, I'll just call this point M. M is equal to 9 plus 3 over 2 and 0 minus 2 over 2. 12 divided by 2 is 6. Minus 2 divided by 2 is minus 1. So we get our middle point, our midpoint. We now need the gradient of BC. Then use perpendicular gradients. So the gradient of BC is equal to minus 2 take away 0 over 9 take away 3. That's minus 2 over 6, which is minus a third. So therefore, the gradient of our perpendicular is equal to 3. M1 times M2 equals minus 1. And we've got a mark there for getting a gradient of BC, then our perpendicular gradient, and then finally to get our equation of a straight line, using our midpoint, y minus b, mx minus a, y plus 1, is 3x minus 6, or y equals 3x minus 18, take away 1 is minus 19 for our final mark. B says the line makes an angle, the line AB makes an angle of 45 degrees with positive direction of the x-axis. Find the equation of AB. So we're going to find the gradient using tan theta, and then use the point A to find the equation of the straight line. That'll be M equals tan of 45 degrees, which equals 1, and our point. So the point we've got is point B, which is 3, 0. So our point is 3, 0. So y minus 0 equals 1x minus 3, or y equals x take away 3. And we've got 2 marks here. Part C. Find the coordinates of the point of intersection of AB and the perpendicular bisector BC. Simultaneous equations in other words. So we've got 2 equations, 3x minus 19 and x minus 3. Y equals 3x minus 19, y equals x minus 3. Since they're both y equals, I can say that this side equals this side. So we get 3x minus 19 equals x minus 3. So 2x equals 19, take away 3 is 16. X is equal to 8. So we get 8 and then sub it in to get y. Well, we know that y equals x minus 3, which is 8 minus 3, which is 5. The coordinates of the point of intersection are 8, 5. And we're done there. Great Higher Maths 2018, paper 1, question 8. The line has the equation y minus root 3x plus 5 equals 0. Determine the angle the line makes with the positive direction of the x-axis. Well, gradient equals tan theta if it's talking about angle and gradients. So let's get the gradient first. So y equals root 3x, take away 5, putting it in mx plus c form. Our gradient equals root 3, and gradient equals tan theta, which is equal to root 3. So theta is the inverse tan of root 3. The inverse tan of root 3 is 60 degrees, or pi over 3. And we're done there, it's an exact value. QA Higher Maths 2019, paper 1, question 7. The line L makes a 30 degree angle with positive direction of x-axis. Find the equation of a line perpendicular passing through 0 minus 4. Gradient equals tan of 30, which is equal to root 3. 1 over root 3. So that means the gradient of our perpendicular is equal to minus root 3, since m1 times m2 equals minus 1. And then we can just use y minus b, y plus 4 then equals minus root 3 x minus 0. So y equals minus root 3x minus 4, and we're done there. Question 5, a line makes an angle of pi over 3 radians with the y-axis and passes through minus 2, 0 as shown. Determine the equation of the line. Well, with the y-axis, that's not what gradient equals tan theta. It's the positive direction of x-axis, so I'm going to have to get this one here. If you imagine I drew a little line here, these two angles would add up to 90. Well, pi over 3 is 60, so working in angles if you want, you would get 30 degrees. So our gradient is equal to the tan of 30, which is 1 over root 3. And then we've already got a point, so y minus b equals mx minus 8. Y minus 0 is 1 over root 3, x plus 2 minus minus 2. So y equals 1 over root 3x and plus 2 over root 3. And we're done there.
Higher Maths 2023, paper 2, question 1. Triangle PQR has these vertices. Find the equation of the altitude from P. We've already drawn in that it's a right angle, so if I can find the gradient of QR, I'll know the gradient of the perpendicular. So part A, the gradient of QR. I've got 3 minus 8 on the top over 13 minus minus 2. y2 minus y1 over x2 minus x1. 3 take away 8 is negative 5. 13 minus minus 2 is 15. That gives me minus a third. And therefore, the gradient of the perpendicular must be 3, since m1 times m2 equals minus 1. And you always need that statement. So now we can use the point P to get the equation. So P is 5 minus 1. So I can use y minus b, my minus minus 1 equals 3x minus 5. So y plus 1 is 3x minus 15. And therefore y must be 3x minus 16. And we're done there. Part B, calculate the angle beside PR makes the positive direction of the x-axis. Well, we know that gradient equals tan theta. So we need the gradient of PR. So let's look at P and R. We've got R, 3 minus minus 1 on the top, over 13 minus 5 on the bottom. That gives me 4 over 8, which is 1/2. So our tan theta equals 1/2. So the inverse tan of 1/2 equals, using a calculator, you get 26.565 or 26.6 degrees. And we're done there.
It's Great Higher Maths 2015, paper 2, question 1. Quite a standard one this. We're given a triangle and we have to work out the altitude, the median and the point of intersection. So our points that were given in the question are -5 and 7. minus 1 and minus 5, and 13, 3. So altitude first, so it cuts the opposite side at right angles, so I need to use m1 times m2 equals minus 1. So for part A, the gradient of AB is equal to y2 minus y1 over x2 minus x1 minus minus. So that's minus 12 over 4, which is minus 3. Therefore, the gradient of the perpendicular is equal to a third, because m1 times m2 equals minus 1. And you've got 2 marks already for getting the gradient and then the perpendicular gradient, and then using y minus b equals mx minus a. Our point is 13, 3. So we've got y minus 3 is a third of x minus 13. So 3y minus 3 is x minus 13. 3y minus 9 is x minus 13. And we want to make it look like x minus 3y. So taking the 13 over to this side, that gives 4 equals x minus 3y, or x minus 3y equals 4. Just making it look like it's asking in the question. Part B says, find the equation of the median from B. So median means we need to cut AC in half and then use the gradient formula to find the gradient. So a midpoint, this is the average of the x's, minus 5 plus 13 over 2, and the average of the y's, 7 plus 3 over 2. 13 minus 5 is 8, divided by 2 is 4, and then 7 plus 3 is 5, 10 divided by 2 is 5. So there's our midpoint. So if I call our midpoint, let's call that M. Then the gradient between M and B. B is minus 1, 5. Minus 1, minus 5. So our gradient is equal to y2 minus y1 over x2 minus x1. So just call that x2, y2 and x1, y1. We get minus 5 over minus 1 minus 4 minus 10 over minus 5 is equal to 2. So we get a gradient of 2, and we've got 2 marks so far for our midpoint and our gradient, and then just find the equation. So y plus 5 equals 2x plus 1. So y plus 5 is 2x plus 2, or y equals 2x minus 3, 2 take away 5, and then there's our final mark. Okay, part C, find the point of intersection between the altitude and the median. So we've got 2 equations. We've got x minus 3y equals 4, and we've got the other one we've just worked out. So let's note these down. X minus 3y equals 4, and y equals 2x minus 3. Do this any way you want, but I'll just make them both look the same. So if I taking this one and putting it underneath, we've got y, we've got minus 2x plus y is equal to minus 3, and we've got 2 simultaneous equations we can solve. So times in this one by 2, we get 2x minus 6y equals 8, minus 2x plus y is minus 3, add because the signs are the same. Minus 6 plus 1 is minus 5. 8 plus minus 3 is minus 5. So minus 5y equals minus 5, or y is equal to 1. So minus 5y equals 5. So y equals minus 1. There's our y coordinate, and then subbing it in, so we've got x minus 3y equals 4. So x minus 3 times minus 1 equals 4. X plus 3 equals 4, so x equals 1. So the point of intersection is just 1 minus 1, and we're done there. SQA Higher Maths 2016, Paper 2, Question 1. Another triangle, this time with the state the coordinates of M, the midpoint of QR. So let's take a note of some of these points. We've got 0, minus 4, and R is 10, 6, and Q is minus 6, 2. And then find the equation of PM and median. So part 1, the midpoint of Q and R. So you've got 10 plus 0 over 2, and part 1 we've got minus 6 plus 10 over 2, and then we've got 2 plus 6 over 2. That's equal to 4 over 2, which is 2, 8 over 2, which is 4. Our midpoint is 2, 4. Part 2, find the equation of PM, the median through P. Okay, so the gradient of PM, we've got 4 minus minus 4, and we've got 2 minus 0. That's 8 over 2, which is 4. Now we can use y minus b equals mx minus a. P is 0 minus 4, so we've got y plus 4 is equal to 4x minus 0, or y equals 4x minus 4. And we're done there. Part B. Find the equation of the line L passing through M and perpendicular to PR. So we're looking for the line that is perpendicular to this one. So it's perpendicular to PR. So we need the gradient of PR. And we'll use perpendicular. So it's 6 minus minus 4. And 10 minus 0. That's 10 over 10, which is 1. Therefore, the gradient of the perpendicular is minus 1, because m1 times m2 equals minus 1. And then the point we're using, it passes through m. Well, we know m's 2, 4. So that's our A and our B. So we've got y minus 4 equals 1 minus 1 x minus 2. Y minus 4 is minus x plus 2, or y equals minus x plus 6. And that gives us our second equation. Third question says, show the line L passes through the midpoint of PR. So we need to find the midpoint of PR and show that the line passes through it. So midpoint of PR, part C. Zero plus 10 and minus 4 plus 6. 0 plus 10 over 2, minus 4 plus 6 over 2. That's 5. That's 1. So we've got to point 5, 1, and we need to show that our line passes through that point. So we might as well just substitute the x part in and see what we get for the y part. So when x equals 5, we've got y equals minus x plus 6. So y equals minus 5 plus 6, which equals 1. And then when y equals 1, y equals minus x plus 6, 1 equals minus x plus 6. So minus 5 equals minus x, or x equals 5. So we've just shown that 1 and 5 both work, and therefore the line passes through the midpoint of PR. And we're done there. SQA Higher Maths 2017 Paper 1 Question 7. A, B and C are vertices of a triangle. Find the equation of a median through C. So there's A, there's a B, there's a C out here somewhere. Really a bad sketch, but it is a triangle. A median cuts the opposite side in half. So we made the midpoint, always call this M. M equals the midpoint of A and B, so we've got minus 3 plus 7 over 2. And we've got 5 plus 9 over 2. 7 minus 3 is 4, divided by 2 is 2. 5 plus 9 is 14, divided by 2 is 7. So we get our midpoint of 2, 7. Now, our midpoint is 2, 7, so our gradient of M to C, well, C, we've got 11 minus 7 on top, over 2 minus 2 on the bottom. 11 minus 7 is 4 over 0. Oh, wait a minute, we're dividing by 0, we can't do that. Therefore, vertical line. If you get an undefined gradient, it is a vertical line. Gradient is undefined. The equation of a vertical line is just x equals. So the equation is x equals. And you should be able to see this. The x part is 2 here. It's also 2 here. So if you ever get that the same x, then the equation is x equals. If it's the same y, the equation would be horizontal, it would be y equals x equals 2. And we're done. SQA Higher Maths 2017, Paper 2, Question 1. Again, we've got a triangle showing. It says the coordinates of B are 3, 0, and C is 9 minus 2. And the broken line is a perpendicular bisector of BC. Find the equation of a perpendicular bisector. So for an equation, we need a point and a gradient. So we're going to need to find the midpoint, let's just call that M, and then we can find the gradient. So for part A, the midpoint, 3 plus 9 over 2, 0 minus 2 over 2. That is equal to 6 minus 1 for our midpoint. So the gradient of BC is minus 2 take away 0 over 9 take away 3 minus 2 over 6, which is minus a third. And then, since we know of perpendicular, the gradient of our perpendicular is equal to 3 because M1 times M2 is minus 1. So there's our key thing there. And we've also got our point. So y minus b equals m x minus a. It was minus 1, so it became plus 1. So y plus 1 is 3x minus 18. So y is 3x minus 19. And we've got our mark there. Part B. The line makes AB makes an angle of 45 degrees with the positive direction of the x-axis. Find AB. Gradient equals tan theta. Gradient equals a tan of 45 degrees, which is equal to 1. And then we have to find the equation of AB. So pick a point. Well, we're going to pick point B is 3, 0. So our point is 3, 0. Y minus 0 is 1x minus 3. So y equals x minus 3. And we're done there. Part C, find the coordinates of the point of intersections of AB and the perpendicular bisector BC. Solve simultaneous equations. So we've got two equations, y equals 3x minus 19 and y equals x minus 3. So we can say that 3x minus 19 equals x minus 3. So 2x equals 19 take away 3 is 16, so x is equal to 8. Subbing that in to y equals x minus 3, we get 8 minus 3, which is 5. The point of intersection is 8, 5, and we're done there. SQA Higher Maths 2018, Paper 1, Question 1. PQ has a triangle with vertices P minus 2, 4, R, Q, 4, 0, and R, 3, 6. Find the equation of a median through R. A median cuts the opposite line in half. It even shows you that, so let's call that M. To work out M, we can do minus 2 plus 4 divided by 2, and 4 plus 0 divided by 2. That gives a 4 take away 2 is 2, divided by 2 is 1, and 4 divided by 2 is 2. So we've got our midpoint, so we can now do the gradient between M and R, because it's not perpendicular, and then use y minus b equals mx minus a. So the gradient between M and R, we can do 6 take away 2, y2 minus y1, over 3 take away 1, x2 minus x1. That gives us 4 on the top and 2 on the bottom, which is 2. And now just use y minus b is mx minus a. So I've got y minus 2 is 2x minus 1. Y minus 2 is 2x minus 2. So y equals 2x minus 2 plus 2 is 0. SQA Higher Maths 2018, Paper 2, Question 5. PQR is triangle PQ and R with the numbers on it, 3, 4, 9, minus 2. Part A, find the equation of L1, the perpendicular bisector of PQ. So if it's perpendicular bisector, it cuts it in half at right angles. So if we call this point M, our midpoint is equal to 9 plus 3 divided by 2 and minus 2 plus 4 divided by 2. That equals 12 divided by 2 is 6. 4 take away 2 is 2, divided by 2 is 1. So our midpoint is 6, 1. The gradient between P and Q, minus 2 take away 4 on the top, and 9 take away 3 in the bottom. That is minus 6 over 6, which is minus 1. So then continuing to work on this one, the gradient of our perpendicular is now equal to 1 because m1 times m2 equals minus 1. And the point we're using is 6, 1. So y minus 6 is 1. So y minus 1 is 1 times x minus 6, or y equals x minus 6 plus 1 is minus 5. The equation L2, the perpendicular bisector PR is 3y plus x is 25. Find coordinates of the point of intersection between L1 and L2. So 3y plus x equals 25 is one equation, and y equals x minus 5 is the other one. So making this one look the same, we would have y minus x equals minus 5. Because the y is an x on both sides, we can add them together to get 4y equals 25 minus 5 is 20. So y equals 5. And since we know that y equals x minus 5, 5 equals x minus 5, so x equals 10. Our point is 10, 5, x and y. So we know the centre of our circle is 10, 5. And for the equation of a circle, you need two things. You need the centre and you need how big the radius is. The distance formula between the centre and one of the points, let's just use C and Q. So the distance I'm going to try and work out is this distance here because that will be my radius. So my radius is going to equal the square root of 10 minus 9 squared plus 5 minus 2 squared. x2 minus x1 squared plus y2 minus y1 squared. And that equals the square root of 10 minus 9 is 1 squared. 5 plus 2 is 7, so it's plus 7 squared. 1 squared is 1, 7 is 49, that is 50. And now, once you do circles, you'll see this, but very briefly, the equation of a circle, and you're given it in the start of exam paper, is x minus a squared plus y minus b squared equals r squared, where a and b is the centre of your circle. So the equation of this circle is simply x minus 10 all squared plus y minus 5 all squared, and the radius squared is just 50. And we're done there for our final mark. SQA Higher Maths 2019, Paper 2, Question 1. We had this picture, and A was minus 5 minus 12, B is 11 minus 8, and C is minus 3 minus 3, 6. And fairly standard, find the equation of median, then the altitude, then the point of intersection. So the median of BD, so just working out exactly what it's asking me. This is the median they're asking us, so we're cutting this one in half. So I need the midpoint of A to C. So part A, I'll call D as the midpoint of A to C. So we've got minus 5 minus 3 divided by 2, and we've got minus 12 plus 6. divided by 2. That's minus 8 over 2 is minus 4, and that's 6 over 2, which is 3. So we get our midpoint of minus 4, 3. So that is minus 8 over 2, which is minus 4, and minus 6 over 2, which is minus 3. So now we can do our gradient between D and B because we don't know anything about it. It's not perpendicular. So the gradient of B to D, y2 minus y1 over x2 minus x1. So I'll just use minus 8 minus minus 3 on the top, and 11 minus minus 4 on the bottom. So you've got minus 8 plus 3 is minus 5, over 11 plus 4 is 15. That equals minus a third. So y minus b equals mx minus a. You can use either the midpoint or point B. I'm just going to use the one that's sitting right here. So I've got y plus 3 is minus a third, x plus 4. So I can do 3 times y plus 3 is minus 1 times x plus 4. Taking the denominator away, 3y plus 9 is minus x minus 4. Or 3y plus x equals minus 13. And we're done there, and that's fine. So for the altitude, we are going to need to find the gradient between C and B. So just a reminder, C equals minus 3, 6. And B was equal to 11 minus 8. So our gradient is equal to minus 8 minus 6 over 11 minus minus 3. That's minus 8 minus 14 over 14, which is minus 1. So the gradient of our perpendicular is equal to 1 because m1 times m2 equals minus 1. And then we need a point. So for altitude A to E, we can use point A, minus 5, 12, minus 5, minus 12. So our point A, minus 5, minus 12. So y plus 12 equals 1, x plus 5, or y equals x. 5 take away 12 is minus 7. And we get our second equation. C, find the coordinates of intersection. So we've got two equations, solve them simultaneously. So our first equation was 3y plus x is equal to minus 13, and our second equation was y equals x minus 7. So making them both look the same, I'll have 3y plus x equals minus 13, and I'll have y minus x equals minus 7. We can add them together to get 4y minus 13 plus 7. Minus 13 minus 7 minus 20. So y is equal to minus 5. And now to get our x, y equals x minus 7, remember. So minus 5 equals x minus 7. So x equals minus 5 plus 7, 2. So our point of intersection is 2 minus 5. And we're done there.
History Higher Maths 2021, Paper 2, Question 4 on parallel and perpendicular lines. So we've got a three-part question here. Part A says the line L1 is an altitude through B. Find the equation of L1. So I always like to annotate my lines here to see what it's asking me. So it's through B, so there's B. So I'm going down at right angles because that's what an altitude is. It cuts the line opposite it in right angles. So I am going to need the gradient of this line. but I've not got a point, so if I find the gradient of AC, I can use m1 times m2 equals minus 1, and then I can use the point B and y minus b equals mx minus a. So let's start off with finding the gradient of A to C. A is minus 5, 1, and C is equal to 4 minus 5. So the gradient of AC is equal to y2 minus y1, so minus 5 minus 1, over x2 minus x1, 4 minus minus 5, watch out for that double minus, so that's minus 6 over 9, 4 plus 5, simplify the fraction to minus 2/3. And therefore we can just say the gradient of the, I'll just write altitude is equal to, and we flip it upside down to make it reciprocal and change the sign, 3/2. And that's since m1 times m2 equals minus 1. So we know the gradient of altitude is 3/2, and then the point B is 3, 1. So we're using that gradient in our point, which is 3, 1. So that's our A and that's our B. Y minus B, which is 1, equals m, 3/2, x minus a, x minus 3. When I've got fractions, I usually like to times the other side by the denominator. So that means the 2 comes over to get y minus 1 is equal to 3, x minus 3. And then we just expand and simplify. So we get 2y minus 2 is equal to 3x minus 9. Moving the x's over, we get 2y minus 3x, and moving the number over, minus 9 plus 2 is minus 7. And I'll probably leave it there, but you could write it in the form y equals mx plus c, or ay plus bx equals c. Part B says the line L2 is the perpendicular bisector of AB. Find the equation of L2. So let's annotate our diagram here. It's the perpendicular bisector of AB, so it's the line that goes through AB at right angles and cuts it in half. So we need to find the equation of L2. So we're going to need the gradient. So if we knew the gradient of A and B, we could find the equation of the gradient of the perpendicular. But this is actually quite an easy question. If you look at A and B, it does look horizontal, and it is because the second coordinate is 1 on A and 1 on B. So if it's horizontal, the gradient of AB is automatically 0, and therefore the perpendicular bisector is vertical. So we can just say that. So we've got for part B, A is equal to minus 5, 1, and B is equal to 3, 1. So therefore, the gradient of AB equals 0 since AB is horizontal. And then we can say then the perpendicular bisector is vertical. So now we just need a point, because the equation of vertical lines, if you think it's going straight up and down, okay? So what never changes is the x. It goes along to some fixed point and goes up and down. So the equation of a vertical line is an x equals a number. So we just need the midpoint of A and B since it's perpendicular bisector. So the mid of A and B is equal to, and we can write a little sum, minus 5 plus 3, and then we divide by 2, 1 plus 1, and then we divide by 2. Minus 5 plus 3 is minus 2. Divide that by 2, you get minus 1. 1 plus 1 is 2, divide by 2 is 1. So since that's our midpoint of A and B, the equation of AB is, remember we said it's x fixed point, it's always going to be minus 1. So it's x is equal to minus 1. And we're done there. Part C says determine the coordinates of the points of the intersection between L1 and L2. Well, this is a easier one than normal. Normally you get two simultaneous equations to solve, both these with x and y's, but this time we've just got an x and y in the first one, but we know what x equals 1. So it's simultaneous equations by substitution. So let's write down our equations again. We've got 2y minus 3x equals minus 7. And we've also got x equals minus 1. So we already know that the x part of the coordinate is going to be minus 1. We just need to find the y. So subbing it in, we get 2 times y minus 3 times minus 1 equals minus 7, and solve that equation. So 2y, 3 times 1 is 3, minus times a minus is a plus, equals minus 7. Take the 3 over to the other side, and that means that y is equal to minus 10. Sorry, 2y equals minus 10, so y is equal to minus 5. So the point of intersection to answer the question is minus 1, minus 5, and we're done there.
Degree Higher Maths 2022, Paper 2, Question 1. Find the equation of altitude for C, the median for B, and the point of intersection. So we've got minus 1 down here. We've got 2 minus 4, and we've got 7, 3. Okay, so first of all, altitude through C. So starting at C, cutting this one at right angles, we need the gradient of A to B. So that's minus 4 minus minus 1 over 2 minus minus 1. Minus 4 add 1 is minus 3 over 3, which is minus 1. So the gradient of our perpendicular is equal to 1 because m1 times m2 equals minus 1. So we've got y minus 3 is 1x minus 7, or y equals x minus 7 add 3 is minus 4. So we've got our equation for our altitude. Part B, find the equation of the median. So median through B means we need the midpoint of A to C. So let's call the midpoint M. We've got minus 1 plus 7 over 2. And you've got minus 1 add 3 over 2. Seven minus 1 is 6, divided by 2 is 3. 3 minus 1 is 2, divided by 2 is 1. So we get 3, 1. So we need the gradient. So using our points 3, 1, and the other point we're going to need to use for our median is point B, 2 minus 4. So we've got minus 4 take away 1 over 2 take away 3. That's minus 5 over minus 1, which is 5. Y minus 1 equals 5x minus 3. So y equals 5x minus 15, add 1 is minus 14. We've now got two equations. Chances are we're going to solve them simultaneously. Find the coordinates of the point of intersection of the altitude and the median. So we've got two equations, y equals x minus 4. And we've got y equals 5x minus 14. So we can say that 5x minus 14 equals x minus 4. That gives us 4x on this side equals minus 4 plus 14 is 10. X is 10 over 4, which is 5 over 2, or you can write 2.5. We know that y equals x minus 4, so that means y equals 2.5 minus 4, which is equal to minus 1.5, or if you prefer, minus 3 over 2. So the point of intersection is 2.5 and minus 1.5. Degree Higher Maths 2023, Paper 1, Question 2. P and Q are points minus 2, 6 and 10, 0. Find the equation of a perpendicular bisector. So if I've got a line, let's say it was here, minus 2, 6 and 10, 0. Perpendicular means at right angles, bisector means in half. So I'm looking for a line that looks like this, I suppose, where that's at right angles and it cuts it in half. So I'm going to need the midpoint and the gradient of perpendicular. So let's start off with gradient. The gradient of P to Q is y2 minus y1, so that's 0 minus 6, over x2 minus x1, 10 minus minus 2, That's negative 6 over 12, which is negative a half. So that means that the gradient of our perpendicular straight away equals 2. And we need to write since m1 times m2 equals minus 1. So we've got our gradient is 2. Now we need our point, so the midpoint. So the mid of PQ, we add the x's. So we've got 10 minus 2 divided by 2, and the y's, 6 plus 0 divided by 2. That gives us 8 over 2 and 6 over 2, which is equal to 4 and 3. So we've now got our point and we've now got our gradient, so we can use y minus b equals mx minus a. So y minus b equals mx minus a, where that's our a and b, and that's our m. So we've got y minus 3 is 2x minus 4. Y minus 3, 2x minus 8. So y is 2x minus 8 add 3 is minus 5. And there we are.
This is Collinear Maths, and today we have looked at the whole higher maths topic. There's no more we can actually do with this. I've given you the whole teaching for the whole topic, and we've went through every single past paper. Hope you liked that, and if you did, give it a like and a thumbs up. We're going to do a video like this for every single topic in higher maths this year. So keep coming back, and if you're new here, give it subscribe to this channel. Take care, stay safe, and goodbye.